This week, we're going to play around a little with printf and see if we can teach it a few interesting new tricks. Hey everybody, welcome back. Today's video is actually inspired by a comment. So I recently posted a video about GUIDs or UUIDs, and my friend Eric mentioned that an interesting follow-up to that video might be to customize printf so that it could handle UUIDs directly by creating a new format specifier. And my first thought was, I don't know if that's a good idea. And my second thought was, why not? I've never done it. I've heard you can do it. So why don't we play around with it and see how this goes? It might be fun. So that's the plan. This video will have source code. And as always, source code is available through Patreon. And a huge thanks to all of you who support this channel. But now back to the video at hand, which is specifically this video, we're going to look at how do we customize printf. I want to also mention that we are heading into non-portable code territory. The stuff that I'm doing today, it's working on my Linux machine. I can't guarantee it's going to work anywhere else. Specifically, it works on glibc, so I've been told, but you've been warned your mileage may vary. So now let's jump into the code. Okay, so let's start out with a trimmed version right here. I've got a trimmed down version of the UUID example that I went through in my previous video. Okay, so I'll put a link down in the description if you missed that one, but the idea today is that, so last time we had our UUIDs we were generating with UUID generate, and we wanted to basically convert it to text so we could print it out like this using printf, right? Well, so the idea today is, what if we don't like this extra step of having to convert to text and then print out as a string? What if we want to just go directly with printf and say, I want to print out something like, let's say, uppercase U, which is currently undefined, but we want to define it. And then the idea here is maybe I can just say my UUID. Right? So the idea would be that I no longer need to convert to text. I no longer need any of this stuff, and I can just have, I'm waiting for my syntax highlighting to catch up. But the idea is that I'm just going to have this line right here, okay? And because it's useful to tell if my code is working, I'm going to put these back in here. I'm really not sure why it didn't spray them all out. But so this is what we're trying to work with. And of course, this isn't just a UUID thing. We could do this with any struct or object. You can kind of think of it like overloading the insertion operator, which people do in C++ all the time when they want to be able to print something out, that's a particular kind of object or any sort of custom formatting, and they don't want to call a separate function like a two-string function. One place that this might be useful, I've several times wanted to be able to just print things out in binary rather than hex. And so what we're talking about today could fit into there, whatever. But the point is that I want printf to be aware of my specific data types and their formatting needs. And there are a few ways that we could get at this. We could try something like a shim. I've talked about those in prior videos. We could download the source code for glibc and modify it directly and then recompile it. And this would work too, but it comes with some portability issues. I mean, it won't work on any other machine unless they're using my specific compiled version of libc. But it turns out that GNU libc does provide us with a more general way to do this, because I guess people actually want to update printf and they anticipated that, and so that's what we're going to play around with. Okay, now for this, we're going to need, the first thing I'm going to do is just come up here. We're going to need to include printf.h. Okay, so this is the header file that kind of defines all the stuff we're going to play with. And I actually found the documentation for this to be a little sketchy. I mean, I was hoping that I could come down here and do something like man printf.h, and I'm not finding much. Now, I did find a page on the GNU libc website about customizing printf. It seems a little bit out of date because it recommends using a deprecated function. We'll look at that in just a minute. But instead, I actually ended up just looking at the printf.h header directly right here. Now, if you look through here, you can see there are some structs. We got some different things defined, some includes. There's a printf info here, which maybe we'll look at a little bit, but this is specifically for defining format specifiers. We do have a couple of type defs. These are function type definition. So there's this printf function, we've got arginfo size function and arginfo function. We'll take a look at those in a minute. And then of course there's a va arg function. But then down here, if we come down here, this is where we're really going to focus mostly, is we've got this register printf specifier. So that's the one I'm going to use today. And down here is the one that was actually recommended in that webpage, which is register printf function, which as you can see has been marked as deprecated. Which of course, if you're not familiar with what deprecated means, it just means that somebody, usually for good reason, has decided that this function isn't a good idea and we should stop using it. Also, deprecated functions often disappear in future versions And so we really shouldn't be using it if we can help it. So we're not going to mess with this function. Instead, we're going to focus on this register printf specifier function. That's going to be the one that we're going to play with today. And so let's jump back to our code and see if we can actually plug it in and make it start working. Okay, so if we come down here, basically at the very beginning of main, I'm just going to call register printf specifier. And this function is going to allow us to basically register some custom functionality, and then printf will hopefully use it. So this function is going to take 3 arguments. The first one is going to be the specifier we're actually going to use. So in this case, we want it to use uppercase U. Uppercase is a good idea because lowercase tends to be used by a bunch of standard options. But basically what I'm doing when I put a U character here is I'm saying keep an eye out for %U somewhere, because that might show up in a printf format string. And then there are 2 more arguments. They are function pointers. Currently, I'm just going to leave them as null for now, and then we'll come back and we'll fill them in, because at this point, the first thing I want to do is just to make sure that everything's compiling. Okay, so if I come down here and compile, it does compile. Note really quick that I am using a makefile. It's a really simple makefile, which is typical for most of my videos. I check out my make videos if this is at all strange. But anyway, looking back, if we compile it, it does compile, but it throws 2 warnings at me. The warnings are basically saying, one, that it doesn't know what %U is, and the second is because it's seeing this extra argument to printf, and it doesn't know how to handle it. But it does compile, and if I come down here and run it, you can see that it runs okay, but it just prints out %U, which isn't really what we're going for, but it's okay for now. It compiles, it's not throwing any errors. So now let's take a look really quick back in our code at what these function pointer arguments actually look like. So the first function pointer argument here that we're going to pass in is a handler. Okay, I'm going to call it uhandler. We call it anything we wanted. And then we're going to have to define this up here. But the idea with this is we're going to make a function. It's going to return an int. Okay, the reason it returns an int is because printf returns an int, which returns the number of characters printed. And so we're just going to help it return the right thing. And so we're going to call this uhandler, and then this is going to take a few different things. One is going to take a stream, so a file pointer to the stream that we're printing to. So this could be standard out, or it could be a file or standard error or whatever. And then we're going to have a couple of different things here. So one is we're going to have a printf info struct pointer. And then we're going to also have a array of const void pointers. So this first one is a pointer to a struct that's going to tell us something about this particular format specifier. And down here, this is going to actually have the arguments that are passed in that are associated with that format specifier. Okay, and then we can come down here and not do that. Let's get... Okay, now we're going to get to these arguments and how the format specifier actually works in just a second. But really quick, again, I just want to see if things work. I want to work incrementally. So let's first start by just saying return f printf. I'm going to print to the stream, and then we're just going to say UUID. So now what this is going to do, I hope, is that it's going to print out UUID in angle brackets whenever we see a %U. So let's come down here, we can compile it, and we're still getting warnings. And those warnings are going to get annoying, and they're never going away because the compiler isn't smart enough to know that I'm actually changing printf. So what I'm going to do for now is I'm going to come in here. You may want to leave them. You may want to take them out for now just because it's going to bug me and kind of muddy things up. I'm going to come in here and say format equals 0. So what this is doing is basically saying that I really don't want any warnings about my format string for printf. So this should allow, let's just make sure we'll clean it and make, this should allow these format errors to disappear. Or they're not errors, they're warnings, but you get the point. And whether or not it's a good idea to suppress these warnings or not, I'll leave that up to you. But in this example, I'm going to, because for now, I think I know better. Okay, now if we come down here and we run it, you can see that it actually does seem to work. It seems to print out the string that we put in there for our %U. So this is progress. Now at this point, our example looks like it's working, but I want to let you know it's not quite working. Because if we jump back here, you notice we still left this second function pointer as null. And this actually tells us something. It basically tells printf how to process the arguments that come after the format string. And so to illustrate this, let's say that instead of just %U, let's say that I also had an integer that I want to put out here. And let's say that I want it to be 67, right? Just arbitrary, but we do sometimes want to print other things other than just our UUIDs. This seems like a pretty normal printf thing to do. So if I come down here and I compile it, you notice again, it compiles just fine, but this time if I run it, well, you notice that I don't get 67 And that is because we haven't told printf what sort of arguments are going along with this %u format specifier. And so it doesn't really know what to do with this right here. So when it actually looks for the information, it looks for the variable to print out for this integer, it's actually going to print out this myUUID instead. And I'm going to get garbage, right? Clearly right here, I got garbage. So in order to fix this, we need to come in here and add one more function. I'm going to call this we'll call it uarginfo, okay? And let's come up here and actually define this function. This one's also going to return an int, and we're going to pass in a few different things. So you're going to pass in a pointer, again, to a struct. So this is printf info. Okay, so this, you recognize this from up here, it got passed in. Now, so far I'm not using these, and I'm not actually sure I'm going to use them, but they've got to be there. And then we're going to pass in a size tn. I believe this is the number of arguments, I think. And then we're going to pass in an array of integers. These are our arg types. It's a pointer here. And then we're going to have a sizes array. Okay, and I'll show you, we're going to take you through kind of what all of these look like. But basically the way this is going to go is we want to check to see if there actually are arguments here. So if our size of our n is greater than 0, and if so, then I'm going to come in here and say argtypes 0. So we're going to set argtype 0 equal to a pointer. The whole point here is that we are saying that this thing, whenever you see %u, the thing that it's going to take is a pointer. And then not only is it a pointer, but let's tell it what size it is. So we're going to say sizes 0. So the first element of the sizes array is going to be size of UUID pointer underscore t pointer. Okay, so now we're just going to come down here and return 1. I believe what this is saying is that there's only one argument for this %u. But like I said, documentation's a little shaky, and I didn't actually dig into this particular one, but I think that's what it means. Okay, now if we come down here, now that we've specified the information about the arguments that are passed in, now if I come down, it compiles again. And if we run it, you notice that we get our UUID and we get 67, right? We no longer get this 1758354 4000, like none of that nonsense. We get what we expected, which is 67. Okay, so now our example is working per se, but we still have this UUID in angle brackets rather than printing out the actual UUID. So there are a bunch of ways we could print out the UUID, but let's just do one of them here. So what I'm going to do is actually grab the argument that's passed in. So let's make a UUID underscore t pointer. We're going to call it u. So this is a pointer to the actual argument that's being passed in. And so what we're going to want is args of 0, right? So args of 0 is actually going to be a pointer to the argument that we're passing in. And so what I'm going to do here, we got to do a little bit of casting. So what I'm going to do is say const UUID underscore t double pointer, because that's actually what it is, even though it's coming in as a void. I got to give it type information so I can actually make use of it. And then we're going to come in here and dereference that. Okay, so this is going to give me a pointer to the argument that's coming in. And then let's make an integer. We're going to call this count. We could call it characters. We could call it bytes, whatever. It's the number of things that have been printed, right? So it's going to be the thing that eventually, let's come down here and remove this. Eventually, we're going to return this count, right? Now, what I'm going to do is just say for int I equals 0, and we'll go all the way up to the size of UUID underscore t, which is going to be 16. There's 16 bytes in here, and we'll increment our counter. And then what I'm going to do, I want to return this, but we do want to call fprintf. So we're going to say count plus equals fprintf to our stream. And then I'm going to come in here and then let's just print it in hex. And I'm just going to print out the value of each character. So this is basically what u points to, and we're going to get the ith character, the ith byte in this UUID. Okay, so this should, if I haven't made any mistakes, this should go through byte by byte and print out each of the bytes in hex for that UUID. So let's come down here and see if it works. So compiles, okay, and you can see, look at that, it actually does work. It's missing the hyphens because I didn't specify the hyphens, and I could come in here to handler and basically print them out however I want. Like, let's say that I only wanted to print out half of it, right? I could just say divided by 2 here, and now I'm only getting half of the UUID. I mean, I don't know why you'd want to do that, but I could go through here and I could insert hyphens wherever I wanted. Like, maybe I could go in here and say every third character, right? So I could say if I mod 3 equals 0, then we could put a hyphen, and no arguments coming in. Okay, so now it's going to insert a bunch of hyphens, not necessarily where they make sense or where they're conventional, but the point is that we could do that. We could make it go after even numbered ones. So like this. And again, none of this really is the point. The point is that we can do it however we want. We can format it in whatever way makes the most sense to our particular application. And so plain and simple, that's how you can customize printf to have different format specifiers that actually work for your data types. Again, I don't know that I would do this normally. I haven't ever done it up till now, and I don't know that it's particularly useful. A couple of my concerns. One is that there's portability issues. This works on my Linux machine, but if I come over here to Mac OS and let's just try to compile it, you notice that it doesn't seem to be working. It doesn't seem to know about this register printf specifier. So there are some portability issues. That's definitely a concern. Also, if a lot of people start doing this, it can affect modularization because people might specify the same format specifiers. You might get collisions, and that could be a bit of an issue. And so if this is something that you actually want to do, and so there are some other ways that you could get at this, maybe through some kind of logging system, which is something that I don't really have time to dig into today, but it's definitely something that you could explore, something we might explore in a future video. But I hope this is interesting, entertaining. I hope you learned something new today. Like the video to tell the YouTube algorithm you want to see more videos like this. Subscribe so you don't miss next week's video. And until next week, happy coding, my friends. I'll see you later.